Hi everyone, my name is Wang Wenxuan. I am currently a PhD student studying at Institute of Automation, Chinese Academy of Sciences and Beijing Academy of Artificial Intelligence. Today I am excited to share our latest work, Unveiling Parts Beyond Objects, towards finer granularity referring expression segmentation with all of you. This presentation will be posted on Thursday morning. I will present our research from the following 5 aspects, which is motivation, contributions, methodology, experimental results and limitations. First, let's talk about the motivation of this work. Referring expression segmentation aims at segmenting the foreground masks of the entities that match the descriptive natural language expression. Previous datasets and methods for classic res task heavily rely on the prior assumption that one expression must refer to object-level targets, which does not take into account the part-level grounding task. However, it is crucial for future multimodal models to act as intelligent agents to realize the fine-grained perception of real world. Therefore, in this paper, we take a step further to finer-grained part-level vision language understanding. The main contributions of this work can be summarized as follows. Firstly, we propose a new multi-grained res task with corresponding benchmark ref COCOM for evaluation, pushing classic res task towards finer granularity understanding of real-world scenes. Secondly, we build a multi-grained visual grounding dataset, namely MRES32M, which to the best of our knowledge is the first grounding dataset that supports part-level vision language annotations and also the largest scale visual grounding dataset. Last but not least, to effectively unify both the object-level and part-level res tasks, we propose a simple yet strong model, namely UniRes, which achieves the new SOTA performance on classic res task and the proposed MRES task. Then, let's talk about the methodology part of this work. This figure illustrates the overall pipeline of our data engine for building the MRES32M dataset. A. We start by fine-tuning a large vision language model to create a capable dense captioner, which can effectively handle captioning tasks at 3 levels of granularity. B. To generate object-level grounding data, we feed images and original bounding boxes into the dense captioner and a powerful segmenter to obtain the captions and masks of various objects. C. We leverage the external knowledge from LLMs to decompose the existing object category annotations into a vocabulary set of part-level tags, which are sequentially fed into an open vocabulary segmenter and our captioner to acquire the part-level annotations. Next, we describe the proposed multi-granularity res model UniRes for the unified MRES task. Since our original intention is to establish a simple and easy-to-follow baseline model for the proposed multi-granularity res task, the structure of our model UniRes is designed to be simple and clean. Our UniRes has 3 major components: the visual and textual backbone for feature extraction, the pixel grouping design for aggregating the low-level and high-level features, and the cascaded 2-stage vision language decoder for multimodal feature fusion and the generation of segmentation masks. As for the experimental results, to evaluate the effectiveness of our method, comprehensive experiments are conducted on 3 classic res datasets in our ref COCOM benchmark for multi-granularity res task, which demonstrate the superiority of our method over previous state-of-the-art methods. In addition, to validate the segmentation quality of our framework, classic res methods CRIS and LAVT, as well as our proposed UniRes, are further adopted for qualitative comparison. The provided visualization results in Fig. 7 convince that our method can generate much better fine-grained segmentation masks of the target objects, greatly reducing the over-segmentation and under-segmentation errors. Besides, we have also provided a few more examples in our newly built MRES32M dataset for visual grounding task in Fig. 9 on the right. More samples can be found in our paper. We conduct extensive ablation experiments on our ref COCOM validation set, including data granularity, data scale, dataset necessity of our MRES32M dataset, and the query-based grouping design. More specific details can be found in our paper. One potential limitation of this work could be that the data scale of our MRES32M and model capacity of UniRes could be scaled up further to push SOTA performance. Moreover, in this work we mainly focus on the MRES task with visual masks as output. It currently cannot produce textual responses and thus cannot handle the tasks related to vision language conversations. However, the integration of large language models could enhance our framework's text comprehension and generation abilities. This opens up a future research direction to develop a more general and powerful framework that could interact with user-provided textual and visual inputs across multiple levels of granularity. Thank you for listening. That's all of my presentation. Welcome to communicate with us via emails and check out for more details in our paper.